Venn diagram, with the help of Venn diagram, is the proper way of proving. To prove, you must take an element on the left set and show that it is also member of the right set. Y belongs to A, Y belongs to A, therefore I can write Y belongs to A, and we find here Y belongs to B, here Y belongs to C, therefore I can say this one. In the next stage we have taken another element belonging to the right hand element and shown that element belongs to also the left hand set, therefore we get this one. Now from 1 and 2 we can say this as P subset of Q, here Q subset of P. Now I prove this second one. Already we have verified that with the help of Venn diagram. Now I prove. Let X be an element of A intersection, that is X belongs to A intersection B. Now from this, since X is belonging to both A and B, we express that by writing X belongs to A and X belongs to B, which can be written as, just I write this one first and this one second. X belongs to B and X belongs to A, so that X is member of B intersection A. I started by taking X belongs to A intersection B, and I get this one, X belongs to B intersection A. Therefore, this set is subset of this one. Therefore, A intersection B is subset of B intersection A. Let me call as 1. Now, actually what I am going to show, already discussed earlier, if X belongs to, X is actually, if A is subset of B and B is subset of A, then A equal to B. We shall use this concept. Therefore, for the left part, we have shown this one. Now, let us take another element which belongs to, let Y belongs to B intersection A. Therefore, Y belongs to B and Y belongs to A. Now, this can be written in this form also. Y belongs to A and Y belongs to B. Therefore, Y belongs to A intersection B. We have started Y belongs to B intersection A, and we have got Y belongs to A intersection B. Therefore, B intersection A is subset of A intersection B. We call that number 2. What we find in the first case, say P is subset of Q, and in the second case Q is subset of P. Therefore, from 1 and 2, A intersection B equal to B intersection A. Proved. if you are asked to prove that two sets are equal, you are to follow these steps. Don't think that Venn diagram, with the help of Venn diagram, is the proper way of proving. To prove, you must take an element on the left set and show that is also member of the right set, and in the second stage you take an element of the right set and show that that is an element of the first set. From these two we conclude A intersection B equal to B intersection A. Now I am going to verify one of the distributive laws, and also I shall prove one with the help of that theory already I have discussed earlier. I am proving and verifying number one. Verification with the help of Venn diagram. First verification, for that we draw these diagrams. Students, you follow. All these are universal set. You mention those outside the box. ABC sets are there. First you draw these round sets. A, B, C, A, B, C, A, B, C. A union B intersection C. First we set the set A is shaded. This is figure 1. Then figure 2. B union C. We said that in the second diagram I have shaded B union C. Then use your concept. What will be A union B intersection C? That means the whole region will be, therefore this is figure 3. A union sorry, actually I have committed mistake here. In the second diagram, for the left hand side, B intersection C is shaded, and in the third figure or diagram, A union B intersection C is shaded. You see, this is the common area, and this shaded part is A union B intersection C. And for RHS, ABC set have been drawn in this diagram also. In this diagram also we have drawn ABC. Next, we follow the right hand part, A union B. A union B. This is figure 4. A union B is shaded. This is figure 5. A union C. A union C is shaded. Now we follow these two diagrams. Then what will be their intersection part? We find here A is in the both diagram, only this common part is present. Therefore, the final diagram, final figure will be this one. A same, and this common part is present in both the diagrams. Therefore, the final diagram will be the shaded part. Figure 6. A union B intersection A union C. Actually, we have shown step by step. For the left hand part, we have got this final diagram. For the right hand part, we have got this final diagram. What we see, these two are identical. Therefore, the comment will be figure 3 and figure 6 are identical. Therefore, A union B intersection C is equal to A union B intersection A union C. Using Venn diagram, we have shown step by step. The final two diagrams are identical. Therefore, we conclude A union B intersection C is equal to A union B intersection A union C. Remember, if you are asked to prove with the help of Venn diagram or verify, then you use Venn diagrams. Now we are going to prove. Now I am going to prove. For that, I have taken an element x on the for the left hand set, that is x belongs to A union B intersection C, which implies x belongs to A or x belongs to B intersection C. Now this can be stated as x belongs to A and x belongs to B. Sorry, it will be or, and x belongs to A or x belongs to C. This statement can be written in this way. X belongs to A. Here also you can take help of Venn diagram. By drawing Venn diagram on the right side, you first be sure that it will be the statement X belongs to A or X belongs to B, and we can say X belongs to A or X belongs to C. That is, X belongs to A union B and X belongs to A union C. From that, X belongs to A union B. Since there is intersection and therefore we have to use here intersection. We started X belongs to A union B intersection C, and through few steps we have come to the step X belongs to A union B and or intersection X belongs to A union C. Therefore, we can say this set is subset of this. A union B intersection C is subset of A union B intersection A union C. I call this number 1. Now, we take another element on the right hand set. Let Y belongs to A union B intersection A union C. Therefore, or you can use the symbol implying Y belongs to A union B and Y belongs to A union C, which implies Y belongs to A or Y belongs to B and Y belongs to A or Y belongs to C. Now I can write this Y belongs to A union B Y belongs to A or Y belongs to B intersection C. Y belongs to A, Y belongs to A. Therefore, I can write Y belongs to A. And we find here Y belongs to B, here Y belongs to C. Therefore, I can say this one B intersection C. That means Y belongs to A union B intersection C. I started this one and got this result. Therefore, I can see this is subset of this. Therefore, A union B intersection A union C is subset of A union B intersection C. This is number 2. Here we have got A union B intersection C is subset of A union B intersection A union C, and here we get A union B intersection A union C is subset of A union B intersection C. Therefore, from 1 and 2, therefore from 1 and 2, A union B intersection C is equal to A union B intersection A union C. This is the way of proving this law, one distributive law. What we have done, first of all, we have taken an element for this set, and we have finally shown that this set is subset of the right hand set, and in the next stage we have taken another element belonging to the right hand element and shown that element belongs to also the left hand set. Therefore we get this one. Now from 1 and 2 we can say this as P subset of Q, here Q subset of P. Therefore P equal to Q. Therefore this law has been proved. We shall in the next class we shall prove more laws and continue.